All right, so the warm-up on the screen is warm-up number 35, and it says, number 1, complete the square and factor. Number 1 reads x squared plus 6x. Number 2, it says simplify square root of -4. Number 3 reads factor by grouping. Polynomial given is x squared plus 10x plus 16. And number 4 reads, find the inverse function f inverse of x for the given function f of x. And the given function is f of x equals 2x plus 6. I'll give you some time to work on that. Now, mind you, you should be able to do numbers 2 and number 3. Number 4, you might remember, maybe not. This is it from Algebra 1. We're bringing it back. We need that. And number 4 is something that I'm getting you close to before we get to the inverse of functions, but it's a step close. So I'm going to go over that one with you guys. So I'm going to go over number 1 and number 4 with you guys, but you should be able to do numbers 2 and 3. So I'll give you some time for that. Copy that and go. All right. It says, number 1, complete the square and factor. So look up to the screen. Now, for those of you that were with me in Algebra 1, I said to complete the square, we need to make this binomial into a trinomial. How do we do that? Look up. By adding one more term. So I'm going to do plus parentheses squared. And what do I write inside of the parentheses? I write 6 over 2. So where did I get the 6 from? Well, it's the coefficient of the middle term. Do you guys see that? So I just got this coefficient divided by 2 squared. And now I'm going to rewrite this. So I bring down the x squared, I bring down the 6x, and then I have, what is 6 divided by 2? 3. What is 3 squared? 9. What we just did, we completed the square. What is that called? Complete the square. We need this for what's coming pretty soon with other functions that we're going to be looking at, okay? However, next step, what are they asking us to do? Well, they're asking us to factor, Mr. Q, all right? The 9 goes on top, and the 6 goes down here. Factors of 9, that add up to 6. That's 3 and 3. 3 times 3 is 9. 3 plus 3 is 6. And I'm going to use a shortcut for this one. So I got parentheses x plus 3 and x plus 3. You guys notice that they're the same factor? Yes, that's why it's a square, because it's the same. Can we rewrite that? Yes, x plus 3 squared. All right, let's go to number 2. Number 2, they give us simplify square root of -4. We did this at the beginning of the school year, remember that? But I'm bringing it back. Let's see. We need to rewrite it. Square root of -4 becomes square root of -1 times square root of 4. I just broke it up. Now, can we find the square root of 4? Yes, the square root of 4 is 2, Mr. Q. All right, so which is the only one that we cannot simplify? Square root of -1, because previously we were in real numbers and that there is no such thing of a square root of a negative number. But now since we're in Algebra 2, now we actually have a name for this. What is it called? Imaginary. So that's why this is an I. So square root of -4 is known as 2i. Once again, I'm bringing these because we're about to get into complex and imaginary numbers, so I want to give you guys some practice with that. Let's go to number 3. For number 3, it says factor by grouping. Well, first let's start with breaking this one up. 16 goes on top and 10 on the bottom. What factors of the 16 add up to 10? Oh, so that is 2 and 8. 2 times 8 is 16, 2 plus 8 is 10. However, I can no longer write the shortcut version because here they're asking us to do what? By grouping. So that means I need to bring the first term down, x squared. And then from there, instead of bringing the 10x down, I'm going to bring, and I break it up into these two factors that I found, which is plus 2x plus 8x. And then I bring down the plus 16. And now I can factor by grouping. Group, whoa. So what is GCF here? Sorry, hold on guys, let me remove this from here. Okay, did something. All right, GCF here is x, we're left with x plus 2. plus GCF here is 8, and we're left with x plus 2. So my factors are x plus 2, x plus 8. All right, and number 4. For number 4, I need your full attention, please. Writing utensils down, look up to the screen. You'll copy at the end. Here it goes. It says, find the inverse function f inverse of x for the given function f of x. So they give us a given function. Here it is, f of x equals 2x plus 6. All right, to make it into an inverse, we first need to take a step back. So before function notation, I'm going to write it as y notation. So y equals 2x plus, oh my goodness, pen. Hold on. Y equals 2x plus 6. Okay, there it is. All right, now that we have that, what variable is it solved for? It's solved for y. Well, to make it into its inverse, now we need to solve for what? For x. So that means I need to leave x by itself. So I'm going to leave x by itself. So I need to subtract 6. Subtract 6. So I end up with y minus 6 equals 2x. Am I done? No, Mr. Q. All right. So that means at this point, I'm going to divide by 2, divide by 2. So then this is a giant 1. So I'm going to continue over here. So I end up with y minus 6 over 2 equals x. Okay. All right. Look up. Here goes the next part, which is what makes this whole thing work. We started by having it solve for y. Is that correct? Yes. Now we have it solve for what? For x. Well, in order to make it its inverse, look up. All I'm going to do is exchange the variables. So I'm going to rewrite this. X minus 6 over 2 equals 2y. This is what we call the inverse. However, can we leave it equal to y? No, Mr. Q, because we started with a function notation that is equal to y. So if this cannot be equal to y, what is it going to be equal? Let me change the notation. Look up to the screen. Let me simplify this. X divided by 2 is 1/2 x. Negative 6 divided by 2 is negative 3. And instead of writing y, I'm going to write it as an inverse. F inverse of x. This is the inverse of what we started with. Copy that. All right, so that was warm up number 35. Let's move on. So our agenda for today, we have warm up number 35, which we just finished. Today we're moving on to, we're still on transformation of functions. And tonight's home play is only 3 transformations. 3 transformations only. And reminder, today after lunch, we have tutoring. Be there or be elsewhere. Bam. All right. Your asynchronous code is SE3LK. SE3LK. Now, just to clarify, are there any questions as to what to do with that code? No, by now you should know that you go on your own during your asynchronous session, either today or tomorrow, and you go type in the code, you write your period number, which is 3, then your first and last name. From there, you take pictures of the notes for the slides that they're asking you for, whatever slide that is, and you submit your work. Simple as that. And that's how I'm going to be checking that you're taking notes. Not that you guys don't take notes. I'm pretty sure you guys take copious notes, right? All right, and your home plate for tonight, it reads, home plate. Do the indicated transformations to the following function. It says graph f of x equals x squared using the domain -2, -1, 0, 1, 2. Then graph the transformations in for part A in green. You're going to transform it using green, and it reads g of x equals parentheses x plus 4 close parentheses squared minus 6. Part B, the transformation is in blue. G of x equals 2 times parentheses x plus 1 close parentheses squared plus 4. Part C is in red, and it reads g of x equals 1/2 times parentheses x minus 5 close parentheses squared minus 3. Copy that. And if you don't have enough time to copy it, remember with your asynchronous code, you're going to see it when you go in. All right, once again, you can find these when you type in your asynchronous code, and you should get it from there. All right, let's move on. Our objective for today, I can transform a function using different parameters. Once again, I can transform a function using different parameters. So if you notice, we're still on the same objective from the time we left before our semester final. So that means we're still using parameters, and we're still transforming, and we're transforming functions. Do we know what functions are? Yes, in your FAIR model, in your own words, you should have a definition, example, non-example, and a hashtag. You're going to do that on your own. Make sure you fill that in without looking at your notes as much as possible. By now, you should know exactly what each part does. All right, from there, quick recap. We talked about parameters, didn't we? Yes, parameters, we said, are a number that transform a certain function into a new function or another function. That's what parameters are. And so far, before we get started with transformations, I said, let's first talk where we started. We started with two variable equations, such as this one, y equals 3x minus 1. But from there, we transformed that by writing it in function notation, where it became f of x equals 3x minus 1. From there, we added a transformation of fx plus 5. And what did we find out that plus 5 did? It moved the entire original function and moved it 5 steps up. From there, we did an entire activity with example Q, given f of x equals 3x minus 1. And the transformation f of x plus 5, we said it moves the entire function up 5 steps. And f of x minus 2 moves the entire function 2 steps down. Are we there so far? So we said whenever we transform it, and I gave you guys this function here, reference points were -1, -2, 1, 2, 3, -2, and 5, 2. And in green, they're asking us to do f of x plus 4, which meant moving it up 4 steps. And in red, f of x minus 4, which means moving it down 4 steps, each of those points. From there, I gave you guys the general rule, g of x equals fx plus k. And now, why is it called g of x? Because we can no longer write it as f of x, because now it's being transformed. The new transformation given will be in g of x form. So g of x equals f of x, and we did plus k. What is k known as? A parameter, and it moves it either up if it's positive or down if it's negative. From there, we moved on, and we said, now let's use a quadratic function. F of x equals x squared with domain -2, -1, 0, 1, 2. And now they gave us to transform, given in green, f of parentheses x minus 5, the minus 5 inside of the parentheses. What does that transformation do to the original function? It moves it to the right 5 steps. From there, the other transformation was f of parentheses x plus 4. What does that plus 4 do? It moved the entire function, original function, 4 steps to the left. From there, we went to this, again, the function, the reference points were once again -1, -2, 1, 2, 3, -2, and 5, 2. And in green, they're asking us to do the transformation of f parentheses x minus 2, which means move all the points 2 steps to the right. And in red, it's f of x plus 6, which means it moves all the original points 6 steps to the left. From there, I gave you guys the general rule of g of x equals f of x minus h. h being the parameter, and h tells us to either go to the right if it's positive or to the left if it's negative. Does that ring a bell? Yes? Yes, Mr. Q. From there, I gave you guys this general rule, now including both parameters, h and k. And the general rule was g of x equals f of x minus h plus k. And once again, we said that k moves it up and down and h moves it side to side. All right, from there, the last activity that we did, I gave you guys a cubic function here. It's already graphed, and I just wanted you to see and to use the transformation given. So f of x plus 2, the plus 2 moves all the points up 2 steps. F of x minus 3 moves all the points 3 steps down. F of x and minus 6 inside of the parentheses moves the entire function 6 steps to the right. And f of x plus 7 with the plus 7 inside of the parentheses moves the entire function 7 steps to the left. And there are the graphs. And we did that. That was the last transformation that we did before we went to break. Okay? So today, we're adding one more parameter. Now, I don't know if you guys remember, here's my remote for my drone. You guys remember I showed you this? Yeah? And this is my remote for the drone, my 4K drone. And each button and each joystick are these 2 little levers here, have a function. So this one on the left, this one, when I move it up or down, the drone goes in elevation, or either elevates or it comes down in elevation. If I move it left or right, it turns in itself 360 degrees on itself. The one on the right, this joystick, moves the drone to the left, to the right, to the front, or to the back. From there, it's got other buttons. These buttons up here, it moves my camera, either tilts it down or up, left or right. In the back, I have these buttons down here that either I press one, it starts recording the video, or the other ones take pictures. And it does other things, which I'm not going to get into. But what I'm trying to convey here is that this remote has different buttons for different things. Same thing with the parameters that I'm giving you. The parameters that I'm giving you, h and k, did different things. Today, I'm going to give you a new one. So before I give you that new parameter, let's do an exercise really quick. Copy this, please. Example super duper Q. And it reads graph f of x equals x squared using the domain -3, -2, -1, 0, 1, 2, and 3. So I want you to make a table really quick, and it reads x with all that domain and f of x. That's going to be in black. Right next to that, I want you to do another table in green with the same domain. On x is -3, -2, -1, 0, 1, 2, and 3. But on the y value, instead of f of x, you're going to write 3f of x. That's in green. To the right of that, let's do another table in red. The domain is the same from -3 all the way to 3. But for f of x, you're going to write 1/3 f of x. Copy that, and then we'll go over this one together. All right, here we go. So let's start off with the first table, the one in black. We're going to do that in black. So this first table is for graphing f of x equals x squared using the domain -3, -2, -1, 0, 1, and 2, and 3. Now, before we went to break, we said, and I told you this is a parent function, and you need to memorize this process because this is the one we're going to use the most. So check this out. So I'm going to write here, I have x -3, and if the function is x squared, that means I'm going to square -3. What is -3 times -3? 9. -2 times -2, 4. -1 times -1, 1, 0, 1, 4, 9. Now, some of you are like, Mr. Hugh, where did you get that from? Well, if I write my function, I'm going to write it down here. F of parentheses equals parentheses squared. And my first value is -3. So f of -3 equals -3 squared, which is 9. That's where I get the 9. Now, this first one, I'm doing it in black. This is something that we need to do automatically, and this is something that we should have automatically in our noodle because this is known as a parent function. This is the original function of all the quadratics, and then anything after that that we add to that function is a transformation. So let's graph this. Negative 3, 9, negative 3, 9, negative 2, 4, negative 2, 4, negative 1, 1, 0, 0. Oh my goodness. 0, 0, 1, 1, 2, 4, 3, 9. All right, let's graph that. And once again, what is that? That's our parent function. All right. All right, look up to the screen, write your utensils down. Here we go. Write your utensils down, look up to the screen. I'm gonna go to the first transformation, which is this table in green. I'm gonna switch to green. But look at what it says. It says X is the same domain, but the next column it's 3f of X. What does that mean, Mr. Q? Well, when the 3 is in front or on the left side of f of X, that means it's implying multiplication. Multiplication. So what does that mean? That 3 is going to multiply f of X. So where is f of X, guys? F of X is over here on the first parent function, on the original parent function. So what does that mean, Mr. Q? That for each of these values, we're going to multiply in times what? Times 3. So what is my first f of X value? 9. What is 9 times 3? 27. Next one, 4. What is 4 times 3? 12. Next one, what is 1 times 3? 3. 0 times 3? 0. 1 times 3? 3. 4 times 3? 12. 9 times 3? 27. All right, copy that, and then we're going to graph it. Now, mind you, negative 327, it's way off the chart, so we're not really going to graph that. We're going to keep it in our noodle as a, mental note, but we are going to graph the other points. Negative 212. Negative 212 is over here. Negative 1, 3. Negative 1, 3. 0, 0. 1, 3. 2, 12. And let's graph that. All right, so once again, we started with the parent function f of X equals X squared. Now we have a transformation in green. Now we're gonna move on to the next one. And we'll elaborate once we get there in a little bit. Let's go to the next one. So this one, it said 3 times f of X. So we multiplied each of the f of X times 3. Look at the red one. What does a red one tell us? 1/3 times f of X, is that correct? So let me show you the first one here. So I'm gonna write 1/3 times, once again, what was the original f of X when X is negative 3? Well, the original f of X is 9. So I need to multiply 1/3 times 9, which is, oh my goodness, hold on. Okay, here we go. So this is 9/3, which is 3, and that goes right there. Let's do the next one. The next one is, once again, 1/3 times, what's my next value for f of X? The next value is 4, so I need to multiply times 4. 4 times 1/3 is 4/3, and what is 4 divided by 3? 1.3. That goes right there. Next, 1/3 again, times, when x is -1, what is our f of x? Our f of x is 1. So 1/3 times 1, and that leaves us with 1/3. 1/3. 0, 0, 0, 0. And the rest of them repeat. You guys notice that because it's a parabola? Yes. So then we have 1/3. We got 1.3, and we got 3. Okay. So let's graph this. -3, 3. -2, 1 and 1/3, which is right there. -1 and 1/3. 0, 0, 1 and 1/3. 2 and 1, 1/3. And 3, 3. Okay. So let's look at them. So we started with the parent function f of x, which is the one in black. And I'll label that over here so I know that that's my parent function. Okay. And then we did a transformation in green, and we multiplied times 3. There it is. And then we did a transformation in red, which is times 1/3, and there it is. So think about it like this. Look up to the screen. Think about this parent function being a rubber band. Here it is. I got my rubber band. I placed it here on my little pegboard. There it is. And I made this black function. So let's say your little cousin walks in right now, and you want to explain to them what to do to the original function to make it into a green one. What are you going to tell them to do? To make it into the green one, the original black parent function, what are you going to tell your little cousin to do to make it into a green one? What do you think, Addie?
You make it like skinnier, or you bring it in because
yeah, so it's a rubber. So it's a rubber band. So what would you tell them to do?
You stretch it long ways.
Stretch it. Yeah, stretch it. So if you notice, guys, the green one stretched it. And if we are going to use proper terminology, we stretch it vertically. Okay. So if that's true, what do you tell your little cousin to do to make it into a red one, Danny?
Extend it, like pull it out more, I guess.
Close. So the green one stretched. What would be another proper word to make it like the red one? What do you think, Alyssa?
Like let go of it so it's loose, kind of.
Let go of it, or, so here we go. Here are the words that I'm going to use. The green one stretches, the red one compresses. Stretch, compress. Stretch and compress. Okay. So let's look at these numbers. When it's stretched, the coefficient here for f of x was a +3. To compress, the coefficient here on the red one was 1/3. +3, +1/3. So what do you think is going to happen? Look up. If I gave you another transformation in blue, I mean in green, and it was 5 f of x. And over here for the red one, I gave you a new one, 1/8 f of x. What do you think, Roman? What do you think the green one would do, and what would you think the red one would do again?
Wouldn't the green one stretch it vertically?
Yeah. So the green one stretches vertically, and the 1/8 compresses it vertically. Okay.
Yeah.
Yeah. So if I continue giving you those numbers like that, can we generalize the idea? What would you guys say? When does it stretch? And when does it compress? Look at it. Don't say it out loud. Compress. When does it stretch? And when does it compress? Let's see. What do you think, Alberto? When does it stretch? If we generalize the idea. Help them out, Giselle. When does it stretch?
It stretches with the smaller numbers, or with multiplying smaller numbers, and compresses with bigger numbers.
Close, the other way around. Look at the, this one was a big number, the 3 and the 5, and what does it do? It becomes a green one, so it stretches, and the other one's compressed. So with whole numbers, it stretches when we multiply, and with fractions or decimals, it compresses. That is correct. So that's the new parameter that we're adding today. What were the other two that we did? The other ones moved it either up and down or left and right. Today, it's either going to stretch or compress, okay? So how does the rule now, the general rule, look with all three parameters? Let me show you. Here it goes. Copy this. Our general rule now looks like this. G of x equals a times f of parentheses x minus h close parentheses plus k. This rule now has all three different parameters. You're like, oh man, Mr. Q, I know, right? So I'm gonna circle the k right here, the plus k. And what does that do? Well, this parameter makes our function either go up if it's positive or down if it's negative. I'm gonna box the letter h, the parameter h. And what does that parameter do to the entire original function? It moves it either to the right if it's a positive number or to the left if it's a negative number. That is correct. So if that's true, what did we just do right now? We multiplied f of x times this parameter. What is this parameter? I'm going to put a triangle next to it or around it. Parameter a. What does it do to the original function? Parameter a either stretches or compresses. And it does it which way? Vertically. And what did we say? Once again, it stretches when? Angie, what do you think? It stretches, when does it stretch?
When it's a whole number.
When you multiply, yes, multiply times a whole number. So if that's true, then it's going to compress when we multiply times a fraction or a decimal. And we'll talk about more of the values once we get to the other transformations, but for right now, just keep that in mind. Okay, so, and if you notice, I'm building up, if you think about it, there's my general rule. It's kind of like this remote, my drone remote. Now I'm building up like all the little functions for the different values, and I'm giving you more parameters, okay? So now that we have those, let's do one that has all the parameters in one. About them apples, yeah? Yeah, let's go, Algebra 2 second semester. Let's go. Let's do this. All right, here we go. Once again, your coordinate plane, make sure you have it from -15 to 15 if possible, from domain and range. And example Star Wars Q reads, graph f of x equals x squared using the domain -2, -1, 0, 1, 2. Then graph the transformation g of x equals 3 parentheses x minus 4 close parentheses squared plus 2. You're like, oh yeah, Mr. Q. I know, right? Let's go. Copy that. I'll give you some time. All right, here we go. So, what do we know up to right there? we know how to graph f of x equals x squared using that domain -2, -1, 0, 1, and 2. Do we know how to do that? Yes, Mr. Q. So down here, I'm going to make a table. X, f of x. -2. What is -2 squared? Because that's what it is, right? Squared. -2 squared is 4. -1, what is -1 squared? 1. 0 squared, 0. 1 squared, 1. 2 squared, 4. And why is it that we do this one pretty fast? Because this is known as our what? Our parent function. Let's graph that. -2, 4. -1, 1. 0, 0. Oh my goodness. 0, 0, 1, 1, 2, 4. There's our parabola right there. Okay. All right. Any questions up to right there? We're good, right? Yes, Mr. Q. All right. Writing utensils down really quick. Look up to the screen. Okay, so this is our original function, our parent function. This is what they want us to come up with, this transformed function. Look up. If this +2 is outside of the parentheses, what parameter does that correspond to? Hold on. What parameter does that correspond to? This is parameter K. Yes. The 4 is inside of the parentheses with X. What parameter does that belong to? Yeah, that is correct. H. Bam. I see you. See you guys? Let's go. Which means if 3 is multiplying the parentheses, that means this is our A. Does that make sense? Yeah? So before we do anything, look up to the screen. We know what K is going to do to the entire function. It's going to move it which way? Yeah, it's going to go up 2. That is correct. What is the 4 going to do to the entire function? It's going to go to the right 4. That is correct. So we don't need to worry about H and K. Which is the only one we need to worry about right now? A, because we want to know whether it's going to stretch it or compress it. So let's make a prediction. It's a 3. What is it going to do to the entire function, guys?
Stretch it.
Yeah, it's going to stretch it because it's a whole number. So let's show the transformation for the stretch only right now. So this is what I'm going to do. Look up. I'm going to add another column here to my table in blue. And it's a factor of what? 3. So I'm going to multiply 3 times the original f of x because I want to see what it's going to look like transformed or stretch or compressed. So let's see. What is 3 times f of x, which is 4, 12. 3 times 1, 3. 3 times 0, 0. 3 times 1, 3. 3 times 4, 12. Let's graph that to see if it stretched it or compressed it. So my x value is -2, my y value is 12. -2, 12. -1, 3. 0, 0. 1, 3. 2, 12. Was our prediction pretty on? Yes? Yeah, it stretched it. But what is our last thing that we need to do? What do you think, Giselle? What is the last thing we need to do now that we stretched it? Have we done any, what else do we need to do? Right now we only
The
did
rest, the H
Yeah.
and the K.
Yeah, the H and the K. So what do I do to each point, Giselle? Move it what?
To the right 4 times.
and
Up to.
that is correct. So I'm going to start with this point up here. So I'm going to move it 4 to the right and 2 up. So I go 1, 2, 3, 4, 1, 2, and I place it right there. I'm going to leave that in red. Let me go to my next point on the blue one, because that's the one we're moving, right? So I'm going to do that again. 1, 2, 3, 4, 1, 2. This one. 1, 2, 3, 4, 1, 2. This one. 1, 2, 3, 4, 1, 2. And this one. 1, 2, 3, 4, 1, 2. And this one we label g of x because that's our final transformation. Let's go. Let's go. Show me with the fingers how come you are with these so far. Yeah, 5 4s, 5 4. Yeah. You're saying, Mr. Q, now I get it. Yeah, because now you just need to look at it through the lens of the general rule and apply it to the original function. But let me go through the process one more time to make sure we got it. First thing, we need to graph the parent function, which is in black. Yes? Yes. From there, identify h and k so that we can do that at the end. Let me repeat that again. H and k when? At the end. From there, we add one column to do the either stretch or compress, which is the factor of 3. There it is. We graph that, and the blue one, which is once it's stretched, then we do our h and k for each of those points of that. Okay? All right, now check this out. This works, this same process works with any function. Once again, it's kind of like a little remote. With any function, the same remote works with any, kind of like any game, if you want to put it like that. And I can apply this same idea to a different function. So look up, I'm going to give you a different function. This is the last one. Look up. Now the function is a what? A cubic function. It's f of x equals x cubed, same domain. And look at the transformation. What's the only thing that changed? Well, some of the parameters, but here the 3 because it's a cubic function. So if I was to ask you to graph that, do you know how to graph that? Yes, Mr. Q. First thing, I get a table going and I do x, f of x. Start with -2. What does that mean? -2 times itself 3 times. What is -2 times -2? 4 times -2, -8. -1. What is -1 times -1? 1 times -1, -1. 0, 0. 1 times 1 times 1, 1. And 2 times 2 times 2, 8. I'm going to graph that. -2, -8. -1, -1. 0, 0. 1, 1. 2, 8. This one is known as our what? Our parent function. Okay, let's look at the transformation. Let's identify K. Look at K and look at H. All right, so what is K going to do? Victor, what is K going to do to the entire function?
So move it 4 to the right.
K. Guys, remember, K is always up and down. If it's a negative, it's going to move down 4. Hayden, how about H? What is H going to do to the entire function?
Move it to the right one.
Close. Remember, this one, since this is a positive here, that means the opposite is a negative. So it's going to go to the left one. Okay? So now that we know what H and K do, and we're going to do that at the end, what are we going to focus on? We're going to focus on right now on this factor, which is A. We're going to add one more column here. And our factor is 3 times f of x. So what is 3 times negative 8? Negative 24. 3 times negative 1, negative 3. 3 times 0 is 0. 3 times 1 is 3. 3 times 8 is 24. Now, obviously, we can't graph these last ones, but these we can. Negative 1, negative 3, negative 1, negative 3, 0, 0, 1, 3. And what did it do? It stretched it. There it is. Are we done? No. What's our last thing? We need to move it 1 to the left and 4 down for each of these points. How many points do we have? 3 of them here on the blue one, 3. So I'm going to go 1 to the left, 1, 2, 3, 4. So 1 to the left, 1, 2, 3, 4. And this one, 1 to the left, 1, 2, 3, 4. And there it is. And that one is our what? Our g of x. Show me your fingers, I'll come here with these. Yeah, 5 4s, 5 4s, 3.5, okay. All right, guys, so your home play for tonight is basically doing 3 full transformations. And here it goes again. Let me go back to the beginning to show you that. Once again, our synchronous code is SE3LK. And your home play, basically you graph f of x equals x squared using the domain negative 2, negative 1, 0, 1, and 2. That's our parent function. And then they give you 3 different transformations, 1 in green, 1 in blue, and 1 in red. Okay. All right. Well, that's our lesson for today, guys. Once again, if you need to come to tutoring, it's after lunch. I'll be here at 1. So be there or be elsewhere. Once again, Happy New Year, guys. Good to see all of you back. So let's go at it. Don't fall behind, all right? Have a good one. See you guys later. Peace. Bye.
Bye, Mr. Q.
Bye.
Later, Mr. Q.
Later.